Welcome back, folks. This is Dr. Tyler Watson, an epidemiologist in the Intermountain West in the United States. I thought I'd take a few minutes to talk about efficacy and how to calculate efficacy, and I'm going to use an example of the most recent FDA approval of the Pfizer COVID vaccine for 5 to 11-year-olds that was submitted or reported on October 29th, 2021. Efficacy is a measure that we use when there's tight controls over the population that we're testing and giving the placebo to. It's a little different than effectiveness, which is a measure of how it would work in the general population. Efficacy is just in the study. And when we look at the data from the COVID-19 study that Pfizer submitted for 5 to 11-year-olds, we see that they gave the vaccine at the dose they said they were going to give it to at 1,305 kids. And of those 1,305 kids, 3 developed COVID. That means the rest did not develop COVID in the time frame of the study, which would leave 1,302. Now, they also had a placebo group, a group of people who they gave just a saltwater shot to, a saline shot, and that was 663 subjects. And out of those 663, 16 developed COVID. That leaves 647 of those people who did not develop COVID. Now, to calculate efficacy, we take the rate of disease in the placebo minus the rate of disease in the treatment group all over the rate of disease in the placebo. So that calculation would be 16 divided by 663 minus 3 over 1305 all over 16 divided by 663. When we do those calculations, we are able to see that the rate of disease in the placebo group is 0.0241, and we subtract that by the rate of disease in the treatment group, which is 0.0229 all over 0.0241. And we get the exact same calculation that Pfizer said we had, which was 90.48 efficacy. That's one measure that's important. Now, in a prevention measure, like vaccinations, we also need to be able to calculate how many people are going to get the vaccine or the treatment that wouldn't have gotten the disease anyway, therefore requiring us to vaccinate more people than what's required to prevent one person from getting disease. And that's a calculation that we call numbers needing treatment, or NNT. And NNT equals 1 over the rate of disease in the placebo minus the rate of disease in the treatment group. And so 1 over 0.0241 minus 0.00229, and that gives us 45.85 people, or 46 people. Now, what does that 46 people mean? It means that we have to give 46 people the COVID shot in this age group before we prevent one child from getting COVID. Now, that's a pretty good measure for a vaccine, that for every 47th patient, we would have prevented one case of disease. The reason it's 46 is because not everybody will get COVID. So there's already a bunch of people who will not get COVID in the first place that are going to get the vaccine. And then there's a group of people who could get COVID even if they get the vaccine, and that's the number we're trying to prevent. The math right here explains how we get to 46 people have to get the shot. I hope that's helpful, and good luck.